All right, so I want to go over the basics of probability, just refreshing your memory from probability, just what it is generally, right? You have a bucket, there are marbles here, some blue, some red, right? So if it said the probability of getting a red marble, it's going to be 2, which is the part out of 1, 2, 3, 4, 5, which is the total, right? So just refreshing your memory about probability, what it usually is. Complementary events are like if you have the probability of rain plus the probability of it not raining, that's going to be 100%, right? Either it's raining or it's not raining. There's no like in between. We don't count drizzle, okay? Combined events. So I'm going to do this one first. Let's just say you have two scenarios. You have students who are taking math, students who are taking science, students who are taking both in the middle, and then the total is our universal set, right? Altogether, how many students there are. So if we wanted to figure this out, right? So probability of A or B, so the probability of math or science is going to equal the total number of math, right? So probability of math plus we're going to do the total number of science, people who are taking science altogether, and we're going to subtract from it. You see how these right here, they're double hatched. These students are double counted. They're counted with the math and with the science, so we want to take them out. So minus the probability of math and science, right? Minus these people, okay? We're taking them out. Mutually exclusive means that one has nothing to do with the other. So the probability of A or B is literally just the probability of A plus the probability of B, right? So for example, going back to these marbles, right? The probability of getting blue, right? Blue marbles plus the probability of getting a red marble, probability of getting a red marble is going to equal to the probability of A and B, right? So that's going to be the probability of A and, I'm sorry, A or B, A or B, okay? Because one doesn't have anything to do with the other, and there's no marble that can be blue and red, okay, or blue or red. It just has to be one or the other, okay? So this is if they are mutually exclusive, which means that one has nothing to do with the other. All right. Conditional probability. We're going to talk a little bit about this, and this is anytime you see the word given. So for given, the best way I can say this is if I ask you for the probability that someone is taking math, given this symbol right here means given, that they're taking science, what we want to do is we want to look for the number of students that are taking both math and science, right? Math and science. So how many students are taking both math and science, which is like this group right here. So if I tell you that there are 10 students that are taking both math and science, the 10 would go on top over, right? Whatever's on the second one, right? The S, the total number of science students. So let's just say I told you that the total number of science students is equal to 100, right? The total science, so probability of science is equal to 100, and that's everything, right? If you are taking a science class, you are in that 100. That's the total number that goes on the bottom. So the probability of math given science, all we have to do is take this fraction and simplify it. So math given science is going to equal 10 out of 100, which is the same thing as 1 out of 10, okay? So I can write this as 1 over 10, and that would be my probability of math given science, okay? I hope that makes a little bit more sense. If two events are independent, this and is just, you're just multiplying these two. You take the probability of A times the probability of B, and you just multiply it, okay? So in the Oxford book, there are a couple of examples of this, and they walk you through it. But hopefully now, in light of, we just talked about intersection, we talked a little bit about uh, union, right, which is the or. Complement is like not something that is not, so probability of rain, right, and the probability of not rain, so R prime, they equal 100%. That's where that's coming from. So complement just means not, something not happening. And conditional, it just gave you a formula, right? It's probability of A given B is always going to be the probability of both A and B divided by whatever second. So the probability of B, okay? So you could write this formula down in our, oops, I cut out the one. In our reference booklet, they write it like this. But if I were to be like, hey, how do I get this part by itself, right? Just divide both sides by A, probability of A. So divide this by probability of A. And so what do you get, right? This cancels out. So you get probability of B given A is equal to, right, this, which is the probability of A and B divided by whatever's second, right? So in this case, the A is second, so probability of A goes on the bottom, okay? So this formula might be easier to remember, but worst case, this is in your formula booklet, so you can go ahead and just refer back to it. So that is given, and we talked about independent, right? If two things are independent, you take the probability of one happening times the probability of the other, and that's the probability of A and B, okay? So that's the basics of probability. The more you practice with this, the better it's going to be. If you get stuck on anything in example 9 now, in light of the lesson that I just talked to you about, and again, this is on Oxford, page 320, please let me know. All right, good job.